What is up, mathletes? This is section 1.6, day 2, special functions. I got 3 different special functions to give you. Here we go. The first one is x squared. It's a what we call a quadratic function, and it's going to produce some funky shaped graphs. Here we go. The rule for taking the input and creating the output is you're going to multiply the input by itself, like x squared. The input is x, it's x squared. So um, 2 times itself is 4, and negative 2 times itself is also positive 4. Anyway, each one of these rows, if you copy them down, each one of these rows represents a point on the graph, and here they are. You can see they're not straight, it's curved. Let's take a look at this graph. We're going to call this shape of the graph a parabola. Everyone say it with me, parabola. Yeah, parabola. This parabola, f of x is equal to x squared is an even function. Why? Because it has y-axis reflectional symmetry. Reflectional symmetry about the y-axis. Here's the y-axis right here, and you can fold this half over here. It's a mirror image. It is up, meaning the end behavior is up, meaning as x gets larger and larger to positive infinity, then the y values will also go to positive infinity. As x goes to negative infinity, then the y values will go to positive infinity as well. They'll just get larger and larger. So on the graph, it goes up and it goes up. That's why we call it up. It is continuous, meaning you can draw the entire shape of a parabola with one fell swoop of your hand. No breaks, no needing to lift your pencil up anywhere. It is not one-to-one, though. It fails the horizontal line test. You draw a horizontal line and you hit 2 points. You'll hit 2 points up here. You'll even see them repeated on the graph. The value of the output of 4 gets repeated twice. The output of 1 gets repeated twice. You can't say that the output of 4 has only one input. It has a minimum of 0 right here. The lowest value on the table is 0. And the lowest point on the graph is 0, the lowest y value on the graph is 0. And where? At x equals 0, right here. It has no maximum value. It just keeps on going up and up. And then the domain is all real numbers. On the table, that means you can take any number you want, and you can produce an output over here. Like any x value will produce a y value. On the graph, that means you collect all the x values of all these points, and you'll end up with all real numbers. The range is 0 to infinity, meaning only on the table will you ever see, you'll never see any negative numbers. You'll only see 0 and the positive numbers. On the graph, that means you collect all the y values of all the points, and you'll only get these numbers, 0, infinity. You won't get any negative numbers. Great. So let's shake it up just a little bit and go x squared minus 3. It's probably going to be very similar. In order to calculate, so the rule says in order to calculate the output, you have to take the input, multiply it by itself, and then subtract 3. So for example, 0 squared is 0, minus 3 is negative 3. 2 squared is 4, minus 3 is positive 1. And the same thing over here, negative 2 squared is 4, minus 3 is positive 1. I think we're going to see a lot of similarities. Each one of these rows makes one of these points, and you connect them in the same shape, parabola. It's still even with y-axis symmetry. It's still up, it's still continuous. It's still not one-to-one, but it has a new minimum. The new minimum is negative 3. It's the lowest value on the table. It's the lowest point on the graph has a y value of negative 3. Where? When x is equal to 0. And that 0, negative 3 shows up as the vertex. It has a new vertex. It's 3 units lower. We're going to call this a vertical shift of negative 3. And the range is also affected. The lowest number of the range used to be 0, now it's negative 3. All right, instead of subtracting 3 after we square, what if we subtract a number before we square? So the rule here is going to be first, inside parentheses, remember PEMDAS says we do the subtraction first and then we square. So for example, 0 is going to be 0 minus 1 squared is still positive 1. 2 minus 1 is 1. When you square it, you get 1. Negative 2 minus 1 is negative 3. When you multiply negative 3 by itself, the negatives cancel out. You get 9, positive 9. Wonder what kind of effect it's going to have here. You take each one of these rows, you plot it here, and that's kind of interesting. It's no longer even because it doesn't have y-axis reflectional symmetry. There is symmetry, it's just about the line x equals positive 1 over here. The vertex is 1, 0, and we'll call that a horizontal shift of +1 because it's just shifting to the right 1 unit, which is really strange because we have a -1 inside the parentheses and that turns into a +1. Everything is positive 1. The vertex is at positive 1. The symmetry is at x equals 1. It's a horizontal shift of +1. And where's the minimum? It's at x equals +1. Kind of strange. Kind of shifty, as it were. Alright, so let's do 2x squared, meaning you take the input, you square it, you multiply by 2, in that order. So it looks exactly like this table, except all these y values are doubled. Because that's what you do. 2 times itself is 4 times 2 is 8. Negative 2 times itself is the same. It's positive 4 times 2 is 8. Each one of the rows corresponds to a point, and wow, look at this. Everything is the same. It still is even, continuous, same symmetry, still fails the horizontal line test. Everything is the same. Even the vertex is the same as the original. 0, 0. Oops. Yeah. But we're just going to call this a vertical dilation of 2, meaning all the y values are twice what they used to be in the original, and so therefore they are twice as far away from the x-axis. Let's talk about absolute values. When you take the absolute value of a number like -2, it becomes positive 2. When you take the absolute value of positive 2, it still is positive 2. It's defined as the distance away from the origin on the number line. So both -2 and positive 2 on a number line are the same distance away. They are 2 units away, so that's why they have the distance. So if the distance is 2 for both of them, then that's what the absolute value is for both of them. So we're going to get these outputs here when you take. So if the rule is take the absolute value of the input, then this is what the outputs are. Each row corresponds to a point, and when you graph them, this is what it looks like. The shape of this, we'll call it a V, and it has even symmetry. It is an even function because it has y-axis reflectional symmetry right here. It is up, up. It is continuous. It is not one-to-one. For the same reason, it fails the horizontal line test. The domain is all real numbers. Wow, this is like exactly the same. All these features right here are exactly repeated down here. Minimum of the minimum y value is 0 right here, where when x is equal to 0 on this table, and there's no maximum. Okay, so all the properties are the same. It's just like straight instead of curved. What happens when we add 2 after the function? We did the same thing here, or a similar thing. We subtracted 3 after squaring here. After taking the absolute value, let's add 2. It looks like when you compare it to the original, all the outputs are 2 units higher. This is +2, +2, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. So it stands to reason that the vertex is 2 units higher, the minimum value is 2, and it's in the same location, the same x value. Let's call this a vertical shift of 2, positive 2. The other one was a vertical shift of -3. Okay, let's try over here. Before we did x minus 1 inside the parentheses, before squaring it, and now we're going to do it here inside the absolute value before PEMDAS, before taking the absolute value. So the rule is first, whatever the input is, add 1 and then take the absolute value. What that looks like here is 0 plus 1 is 1, take the absolute value is 1. 2 plus 1 is 3, take the absolute value is 3. -2 plus 1 is -1, you take the absolute value as +1. It looks like the 0 value has been shifted to the left. You can see it on the graph. It's over here. the vertex is now -1, 0. It's no longer even because it doesn't have y-axis symmetry. Although the symmetry is present, it's just shifted. It's over along the line x equals -1. Well, let's call this a horizontal shift of -1 because, wow, that's really strange because I see a +1 here, and it turns out that all these, the properties have like -1. So that's a horizontal shift of -1. It has a minimum y value of 0 at x equals 1, at x equals -1 right here. All right, let's throw it all together. Let's get real crazy, and let's take 3 of these numbers. Let's take, compared to the original, we've got a -1, a multiplied by 3, and a -5. That's 3 different things we're going to do. The -1 is, the rule is defined as take the input, first subtract 1, then take the absolute value, then multiply by 3, then subtract 5. Whew! Alright, here we go. Let's start with an easy number like 0. 0 minus 1 is -1 times it. Then you take the absolute value as +1. 3 times +1 is 3. Minus 5 is -2. You go through PEMDAS 5 times and you get these numbers. It looks like the symmetry is over here at -5 because you get -2 repeated. So, in summary, the 3, the -1, and the -5 looks like produces a V with a vertex at 1, -5, and we've got a horizontal shift of +1 here. We've got a vertical shift of -5 down here, and we've got a vertical dilation of 3, meaning the slope used to be +1, now the slope is 3. This line right here, you go over 1, up 3, over 1, up 3. That's the slope. I wonder if we could predict where the vertex would be even without graphing it. The parabola's vertex starts at 0, 0. It looks like this +2 would just shift the whole parabola up 2 units. It would have vertical shift of +2. And so therefore, you can say, oh, without even graphing, I know where the vertex is. It's going to be at 0, 2. What about here? This would have, this -5 is outside of the absolute value. So that looks like, if the pattern holds, it would kind of look like this one, where it had a vertical shift of -3. This would have a vertical shift of -5, and the vertex would be at 0, -5. This, because the -1 is inside the parentheses, it'll go before you square it. That's going to be a horizontal shift. But remember how everything was like negative of what we expected. Like I see a -1, so that's going to be a horizontal shift of +1, and the vertex will be 1 unit to the right, 1, 0. So if this were -1 creates a horizontal shift of +1, +4 creates a horizontal shift of -4. Remember, when it's on the inside, it flips around. It's the opposite. And so therefore, the vertex would be at -4, 0. Alright, so this -1 creates a horizontal shift of +1, and this +3 on the outside creates a vertical shift of +3, and the vertex is at 1, 3. I think we're getting the hang of this. We're cool. Alright, so this -4, it's on the inside, therefore it's a horizontal shift of +4, and this is wrong right here. This should be 4, 0. This is also wrong down here. This should be a vertical shift of +2. Because it's outside. This one is inside. Oh man, did I not edit this? Terrible. Horizontal shift of -2. So therefore, we're going to have an vertex at -2. And so here, I want you to tell me what I think I can tell you here that if the +1 is on the inside of an absolute value, then it's going to have a horizontal shift of -1, and if the -2 is outside, it'll have a vertical shift of -2. So when you tell me exactly what number is being covered up here when I find the vertex, it is the y value is -2. In summary, we can say that if a number is inside the function, it's going to have a horizontal. It's going to be a horizontal shift, and then it will have the opposite sign if it's addition or subtraction. And if it's outside the function, it must have something to do with the vertical shift, or even a vertical dilation. So the symmetry in the absolute value functions and the quadratic functions, like functions with x squared, the graph of parabola, is through the y-axis. At least the original version, y equals x squared and y equals absolute value of x. All right. Last function, I'll make it quick. This is the greatest integer function. It's also known as the round down function. And it looks like this, like, whoa, what? It's just two solid brackets. That's how you symbolize it. And basically, the rule is you take your input and you round down to find the output. So 5.6 rounds down to 5. Even the number 5 rounds down to 5. Even the number 5.000001 rounds down to 5. Pi rounds down to 3. Negative numbers get a little tricky because negative 2.6 rounds down to -3. We want to keep on rounding it down towards negative infinity. So negative 4 rounds to -4, but negative 4.00001 rounds down to -5, and 0 rounds to 0. You do all that, you might see, you plot all the numbers, you take every x value and round it down, like 1.1 is a y value would be right here, but it gets rounded down. 1.2 would be right here, rounds down. 1.3 rounds down. 1.9 rounds down. You get these steps. Each one of these is called a step, and so this is the greatest integer function, the round down function. Let's talk about the features of this graph. Is it even a function? Let's test it. Well, and it does. It satisfies the vertical line test because open dots don't count as a function value. So if you had a vertical line right here at 1.5, fine, it only touches one point on the graph. But if you had a vertical line exactly at 1, yes, it only touches 1 point on the graph, and it's right here. This is actually not a function value. It only tells you, it's a boundary point that tells you how far along this step goes. But the function value is right here. Not continuous at all. If you had to draw this, you draw one step, pick up your pencil, draw another step, pick up your pencil, draw another step. Not continuous. There's so many jumps. What is the end behavior? It's kind of fuzzy. I think strictly, I should say no. There is no end behavior. But maybe if you wanted to stretch the definition, at best you could say it's down up, because as x goes to negative infinity, you could say that it's really weird. I'm going to say it's down up, but it's debatable, and depending on how you define it, a strict definition might say that it's not. It has no end behavior. It is definitely not one-to-one, because a horizontal line would, for example, this x-axis is a horizontal line and it touches many points. Fails the horizontal line test. It's not increasing. There are no increasing. All of these intervals are constant. So this interval right here is constant. This interval here is constant. This interval here is constant. So you can't really say that by the definition that we have that it is increasing because it's filled with just constant intervals. And there's no extrema anywhere. There's no maximum value of the function. There's not even a relative maximum, because if you tried to zoom in, let's say 1.5 was the location of a maximum right here, a relative maximum. If you try to zoom in, all of its neighbors have the same y value, so it doesn't really have any extrema. Really weird function to try and talk about these things. That's it for today. Enjoy the calculator time, and I'll see you in class. All right, it's time for you to pause the video. Go get that calculator if you don't already have it. Going to get the calculator. Now that you've got it, you can unpause. And you've already unpaused the video. You can check this out. So we're going to do B graph on the scratch pad. I'm going to go to Tab and type in x squared. Enter. There it is. Isn't that great? Check it out. When the icon looks like 4 arrows, you can drag it around using the trackpad. And you can see that inside and outside it's got horizontal shifts, vertical shifts, which you can edit to your own liking. Let's say it has a x plus 4 and squared and then minus 2 on the outside. You can see it corrects it as well. Tab. Up. Let's go to F1 and you can see there it is. Let's delete the whole thing and press the button next to 9, which brings up the large menu. And let's go find the absolute value. Enter. And type in x. There it is. Absolute value of x. V-shape graph. Tab. Let's edit that to say x minus 1. Enter. And there it is. You can see the horizontal shift of +1. Tab. Up. Delete. Floor. Type in the word floor and in parentheses put an X. There's those steps. Steppity step, 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 up. Tab. Up. +3. They all got higher. Vertical shift of +3. Tab. Up. Delete the whole thing. Enter. There it is. See you tomorrow.